Hello friends, welcome to my channel. Today we will discuss about string and we will cover most of the useful function you need in the string standard library. But before we discuss about string, let me explain some of the theoretical concepts you need to understand before diving into more detail. So I'll talk about the difference between the string literal or ampersand star with the capital string and the string slice. And I'll discuss in terms of how they are related with the memory layout in Rust. In any programming language, or it is even for Rust as well, so the memory layout or it is divided between various segments. So we have a text segment, data, heap, and stack. In the first segment, it has low memory footprint. It has all the machine code. And data segment in the app binary or the exe file, whichever the textual information you create, so that will be reside on the data segment. And you must be heard about the stack and heap memory location. Heap memory are usually used across the board. This is allocated in the runtime. So the size of whatever you are going to store in a heap memory is not predefined. Let's say you call API and retrieve lots of data. So you don't know at the compile time. Those kind of data you want to store in a heap. So the data lives longer than the function. When the function call is exited, so your data allocation in the memory is not clean up by default. But Rust follows a different programming model. We will talk about that in ownership and borrowing a little bit differently. But the idea is that in heap, the unknown size of memory you can store, and that will live longer than the function. So if the larger data you want to store, the stack is not the preferred place. You should store in a heap memory. Whereas stack, like all the primitives, for example, integer, floating point numbers, character, those will be stored in the stack. So a stack also allocated in the runtime, and it doesn't outlive the function. Inside one function, what are the primitives or what are the variables you define? So the execution, once the function is scope is out, so all this data allocated in the stack will be removed. And let us discuss about the variables and where they are stored. So if you define a simple variable let name equal to profile, this is known as string literal. Or inside that, it is represented by ampersand star. So most of the useful string function you can use it, but this would be this kind of string literal will be stored in your source code, whatever the Rust program you are going to write. And after that you compile it, and then you create a binary of that file. For Windows you have to create a exe file, or for Linux other environment some different file, executable file. So whenever you start the program, you execute the program. So at that time, during the booting or the starting of the program, all the data stored in the application binary is passed to this data segment, and this profile will be written into memory. Once you terminate it, then only this memory will be freed. That means that whenever you define a string literal, this would be available throughout that program execution. And one more important thing to note is that even though string literal, people will be thinking that it is located in a stack memory, but it is not. It is on the data location. So this memory won't be freed till your program is crashed or is completed successfully. That's why we have a string type. So this string type is not part of the core language primitive. So this is part of standard library. For a few embedded system, the standard library you have to import additionally. But in most of our program, for our sake, the standard library we can include as part of our program. So we should be good. But the data you created using the string, there are different way we'll talk about more today. So the hello world is a string type. So the data will be allocated in the runtime, and this data allocated in the heap. So whenever you see string, so it will be heap allocated. And how to access it? To access it, it is it created this message is just a pointer. It contains three parts. One is pointer, the length of the string, and the capacity is reserved. So you can define your user defined capacity, or initially the capacity may be larger than the length. So the pointer will point to the address of this first character. So this is a message represented with this pointer, length, and capacity. And in case of other stack memory, for example, if you define a is equal to 30, by default it shall be integer, 32-bit integer. So those things will be defined. There is no pointer concept, no length or capacity. So directly the data will be present in the 30. If you assign it to some other variable like employee age, so the 30 will be copied across, in the stack. So there is no pointer concept here. And if you try to do this, you want to pass this string reference, like message reference, to another function, or you call this using ampersand and range function 0 to 0.5, then that means you are taking a string slice. So the string slice is the type looks like ampersand star, but it is a bit different. This is a string literal, so it would be present in the data part. But this string slice is a part of already allocated in heap memory. So it contains pointer and length. It doesn't contain capacity. So pointer means pointer is the first character, hello, is the address of h, starting point, and it need like length, like up to 5. So till hello. So those two information will pass in the string literal. So hope you got some good ideas about it. Now let's dive into lots of example about string. Today I'll saw lots of example and around 50 to 60. So we should be good learning today. So we have created our first variable name, which contains profile. This is string literal. And using this string literal dot to string, we can create the string type. So the memory allocated for profile will be in the heap. And you want to get this string slice again, you can use name.as star. This is a string slice, not the string literal, because it may possible that in the compile time you don't know what is name content. So this is a string slice. Extra the string slice containing the entire string, but this is a string literal, okay, where you compile time you know that what is the content you are going to put. So this profile is part of the program exe file. At this moment it is part of exe file, but this may be possible that you get from user input or file or some API call. This allocated memory would be allocated in the heap. So this is a very common way to create the string type, string from, and you pass this string literal. And also, like from string literal, if there is a from is there, so using this into, you can create like a string type as well. This is from string literal, you can call into, it will convert to the concrete type. So if you have a string type, you can do plus operation to concatenate with the other string or the string literal. And there is other way also, like println, we are familiar with that. Similar, the syntax format macro. Using format macro, we can construct the string type as well. And another way to convert like string. A string is a vector of bytes. We'll create like one vector representation. We will store some kind of integer values. So this is a UTF representation from UTF-8. You pass this vector and you will get a string. This will return a result enum, which can be valid string type. If the data you are passing is not a valid UTF bytes code, then it will complain. But in our case, we have passed like valid the byte sequence vector U8. U8 for 8 bit or 1 byte. This represents 1 byte data. So this is like UTF-8. But this is one very important aspect. in case of C and C++ programming, by default the string type doesn't support UTF-8 or UTF-16, but Trust provided a built-in support for UTF-8 character. That is a very good thing once we are dealing with internationalization or different character set, which will come very handy. So we have the first function we can use. This is a string. Once we do repeat and we can pass this number of character. So we can, this heart shape is repeated 5 times. And if you want to convert into bytes again, so you can call dot into bytes. So consumes the strings. This particular thing is consume the string. After that, if you try to access this heart, you won't get it because the memory is not copied to 2 times variable. Because you already consumed it and printed it, you could have stored into the variable array again. But I have just using a macro, I just extracted the bytes part from the string. If you see this, it is both the same, 250, 159, and etc. etc. If you try to print this heart again, it will compile error will happen. So borrowed of move value. At this moment, this ownership is transferred and to bytes. There is no heart anymore. Now let me comment it out. Similar to into bytes, there are edge bytes also. There is a slight difference between those two. If you use into bytes, that ownership is already transferred. It is not borrowed one. It consumes the string and convert into bytes and store into some variable, and you can use that variable whatever you like. But this particular case, it borrows the string as bytes. So both will be pointing to the same location. There won't be copy of the data, but you are borrowing it. The ownership is not being transferred. That is the reason we can able to print the bytes as well as string. So by default, the strings are immutable. Like name, if you define, is immutable. But using the mute keyword, we can do any modification to it. The first function is name.post because this string is nothing but a vector of U8, or each U8 is nothing but a character. So string is a collection of character. So by adding, you can add one by one character to it. So we can add any character. In this case, we are adding a space character to this name. And using this post, and if you want to append a string, notice the single quote over here. In the post function, we will only take the character as an argument, and post string take the string type as an argument, like Kumar, string literal. And once you do the debug, we can get the Proful Kumar. Both the string we can append it or concatenate it multiple string. But the important thing that you have to use mute keyword, and post is only for character and post string is for string literal. If you want to access like the first character of it, like you can use like ampersand 0.1, then the P will be written. See? So it is bit slightly complicated. You have to give range if you using like UTF-8 and some kind of Chinese character or Japanese or some kind of other letters. Then 0 to 1 may not written any character. So depending upon the character set you use, you have to use the proper, proper range to it. Because the only this character is in this ASCII code, it represents P. But for all the other character set, the first 0 to 1 is may not, first 0 index may not contain this any character. That is the reason if you want to access 0 directly, so it is not allowed. So we cannot access string using index by integer. Even though string is feel like a vector, vector of U8, but we cannot access using this square bracket notation and zero index. And as I say, string contains three parts. One is pointer. We can access the pointer, and using some unsafe code, we can directly manipulate the data. I'm not going to show that to you today, but it is you can have the raw pointer, and its type is equal to star const U8. So pointer will point to the internal buffer string uses to store the data in the heap, and this pointer address will be stored in a stack. And if you want to get this name, length and capacity, so in this case the Profil Kumar content like length is 12 and capacity is 12, both are same, but capacity may be equal or larger than the length. Now let me explain about the difference between the like capacity and length, the difference. We can create like string message, string new. At this moment there is nothing is allocated into the memory. The capacity initially will be 0, but only we have defined a message variable, but which point to nothing. That's why if you see this capacity, it would be 0. Means you have not allocated. It is bit inexpensive. You just created a variable. Only the type you have mentioned, but there is no capacity allocated in the heap memory. So for this example, this is a mutable message, and I'm just looping it 0 to 5. Nothing fancy over here. And I'm appending this message post string hello 5 times. So, but if you see this length and capacity, capacity 0 is for first time, and length equal to 5, the capacity is 8. Length equal to 10, the capacity becomes 16. Length become 15, then capacity is 16. So capacity is getting doubling each time. Till if it is less than length, it is remaining same. So capacity always allocated double the amount, depending upon your adding a string. So if you allocate capacity in this kind of loop operation, it is wise to specify the capacity in beforehand if you get some ideas. If you know, because allocating capacity all the time is very expensive operation, because it try to, if let's say you allocated heap memory inside heap, and you want to append heap again, then it will try to add that heap alongside with it, but there is no guarantee that you will get all the allocated together. Then it will happen, it will allocate in some other space in the heap, then it will copy that hello and append it and create a different memory location. But if you want to specify like capacity earlier, then it will allocate, reserve the place for you, so that you can append, keep on appending till you reach the capacity level. So in this case, I have applied the capacity as 25, and nothing changed. So if you see this, all this case length changes like 5, 10, 15, 20, but capacity remain constant, 25. Now let's explore some more function. Today I'll show you lots of example about different function we can do with the string. So we define one string here, and we got a star pointer. We can use as mute star to get like a mutable string pointer. But if you see, there is it complaining it, because this message we have to make it mutable. Okay, but this is a mutable string slice. By default, you cannot do lots of string literal is read only, but because we are getting a mutable string type, so we can do some kind of mutable operation. In this case, we are using like there are different uppercase, lowercase. By default, the string are UTF-8 and UTF-16 character. So we can use to lower to uppercase, but that will be slightly differently. But if you know that you are dealing with ASCII character set only, then you can do, because in the same place it won't allocate any other place. Same place it won't change it to uppercase. If you see this rust is a, it all change to uppercases. Similar to this, here we have to convert it to, but you can directly change to lowercase to uppercase into the message directly. We have to make it mutable, but we can make it uppercase, lowercase. And this is one more function which truncate that truncate function. And we can give the length, how many we want to truncate. This is the new length. This length contain like this much, around 10, 12 length or 15. But if we are specifying that we want the message to be up to this new length, like 4. So 0, 1, 2, 3, 4. Rust is only is truncated to till the rust. So the new updated string would be rust. So the truncation will you will provide this new length. How much new length you want to truncate that string to. And there are a couple of more functions. Like pop and remove. Pop will remove the last character. Now our message will contain rust. Pop will remove this T out of it. And if you see, it will return an option. If there is no character available, then it will return a none. But if there is a character present in the last, the string is not empty, then it will return a option or sum with payload T. But remove will, we can provide the index to it. And it won't return any, it won't return option. If the index is not available, then it will panic. But it will return the character of it. In this case, like 0, 1 index is the U is available, so it is written a U. So both T and U removed, both a destructive operation is mutable operation. Now our message contain RS. And remove in case of pop, that because the string, the last character is removed, so there won't be memory allocation, or it won't allocate a different memory all each time you do pop. But remove, because you are reordering this character sequence, then it will each time it will allocate a copy every single element into the buffer and create a new string all the time. So this is a bit interesting function. Like we retain. Inside the retain, we can pass a closure. This closure can return true or false. So if the character is not equal to space, then we are retaining this message. This is a in place change or it directly modify the message. So we, inside the closure, we can write any complicated logic to say that each character by character it will parse. And you can say that this character is not a number. If a character is a number, then only use it, retain, keep it, or discard it. So if this is space, you discard it. If there is not space, you retain it. That's why if you see this is the output string, the space is gone. And using insert function, you can provide this index and you can put the character. So similar to post and poster, you can insert character into the corresponding in a particular index, and you can insert a string as well. So the output is like this underscore is imported and not here is place at index 7. Because it deals with the string, the actually length and characters count may be slightly different sometime, depending upon which character set you are going to use. In this case, length and character count are the same. But if you're using some other character set, this is my native dog Odia. If you see this length and the character count would be different. Length is 24, but actually character count is 8. Now we'll see some of the split operator. There are different kind of split function are available. If you got a string, you can call string dot split off, and you pass the index at what you want to split up the character. I pass 6 here. So Praful and Kumar is being splitted. So this name will contain the Praful, and this last name is contain the Kumar. So split up is going to modify the in place the original variable name. So it will return a other string, but the original string also modified. And at that particular index, 0 to that index, it will be the original keep that string. And after the 6 to last length of the string, that this last name will contain. This is split off. And we have split 8 as well. The split off will change this original string, but split 8 is not going to modify this original string. So it will return to string literal. In this case, is it is a two complete different string type, but this is a tuple it will return. Split 8. It is a read-only access. So last name is the tuple which contains this Praful and Kumar. So split off will modify this original name, but split 8 is only returning that as a tuple. I don't think we have to make it mutable as well. Let me see that. Yeah, in this case we don't have to make mutable, but if you don't do mutable here, it will complain. Yeah, cannot borrow name as mutable. And using clear, you can delete all the content of it. Because we have removed this mutable. For clear, we need this mutable content. And there are some handy function available, is empty, which can check that whether it will return true or false, whether the string is empty or string having some data. Let's continue a few more example. We can use replace range to replace the content to another string. So we can provide this range 6 to this length, 6 to length with the last name Sadangi. So by default, this name would be modified to this name in place name would be modified to the new content, Praful Sadangi. And if you can do replace thing, this will return to a new string type. And Praful will be replaced by John this time. And if you want to multiple occurrence, if you want to replace, here we have ABC couple of times, then you can switch with the count. If you want to do 2, 3, 4, this will replace only once. This will replace multiple times. 1, 2, 3, 1, 2, 3, and so on. And this is one way to get the slice of that string type. You can use this range syntax. Range syntax, if the index is not present, it will throw panic, or it will the program will crash. But if you do get and provide this dot dot means 0 to 6, a profile, and it will return as a sum profile. It is an option type, it will return. If there is no data available, then it will return none. And you can do like into box string. It is helpful for some doing performance optimization or tuning. So if you want to get the string literal, but you want to drop some excess capacity, box will allocate the memory into the heap. The string literal, it will allocate heap, but it will drop the extra space. So here we have our own string type. We can call characters. This characters is an iterator. You have to use mutable keyword to access it. You can use for loop, for each loop, for in loop to go loop through each one of them. But also you can call next function to get one by one character like p. So next will always return a option or some type. So if there is no data, it will return none. So name.characters will return a iterator. Iterator is a very popular trait, and most of the vector and all other different hash map and all other different collection type are implemented some kind of iterator. So this name.characters is also kind of return a iterator. Returns a iterator. So we can use call.next to get to the next values. And if you want this indexes as well, this is also a different iterator. This will be only characters. This is characters with indices. It will say 0, P, and all so on. The next will happen that 1 and R. 1R. This is sum along with the tuple. This is only directly containing the data. This contain like with indices as well. Now we can use split white space. Split white space, Praful Kumar is separated by white space. This also will split and return a split white space, but that is also iterator. To access the iterator, we have to call next. So if your string contain the new line character, so we can call like message of a string dot lines. Then it will return a lines, and it is also iterator. If you do dot next, so Rust is it is returning. So we can use any loop or just to look through this individual lines. And let's say we have a string separated by comma. Then we can call like split operator, and this will also return a iterator. Split iterator. But usually iterator will go hand to hand with collect method. Either you can specify this type over here, like in this case you want to mention, or because split iterator will have a collection of values which can be accessed using next. But if you want to collect it to a vector, you can use a dot collect method and provide the type, so which will convert to a vector type. So if you print like cities, then London, Paris, Berlin will be printed, but in a array format. So we are not looping through ourselves through iterator, but we are converting to the iterator to a collect method, to a vector representation. And there are so many different variation of split methods, like split terminator, split n, and right split, and so on. So you can check the reference documentation to get a more detail about it. These two are very powerful methods. Initially, as a beginner, you may not use it, but it is very powerful. So which contain matches and matches indices. So matches means this is a contain a string. So you are looping through each one by one. If it is numeric, then you are storing into the numbers. Say 1, 3, 6, 7 matches. So all the numbers, you can provide any condition here, or you can pass a closure here as well. This matches, you can pass string, character array, and or a function or a closure. What you want to store, keep, or what you want to discard. Here I am passing and saying that matches, string.matches is numeric. I want to only return this numeric data. Then I am doing again the collect. This is I got a iterator and collect and converting to vector representation. So this 1, 3, 6, 7 is there. And matches indices is like we have seen in this character indices. It will return with the indexes data. Like this one is present in one index, so 1 is returned. So finally, we have like some data which is spaced before and after. We can use different kind of trim. The first kind of trim will remove the spaces both left and right. And this is a trim from start and trim from end. And there are different variation of trims as well, along with some powerful combination of matches as well. So you can explore some of this trim by yourself. And final one for today, like for let's say if your string contain like a host equal to with some data, and you want to split based upon this, you want to remove this host equal to a strip prefix, and you can just get rid of this host prefix, and you can get this data to it with it written as an option. So today we explore lots of different functions available in string. Hope you like it. Have a good day ahead. Bye bye.